Let's talk a little bit about expressions and operators. An expression is a combination of both operators and operands. And when you evaluate an expression, you get a value that has a type. So this is an expression, for example. The value of this expression is 5, and the type would be int, because when you take one int and add it to another int, the result is an int. This is an expression. The value of this resulting expression is going to be a string, because this is going to perform string concatenation. So the type is a string, and the value is the string hello6. This is an expression. The type this is going to evaluate to is going to be a Boolean, because here we're evaluating whether or not 3 is greater than 5. So the type is Boolean, and the value is false. So every expression has a type, and it has a value. Now, Java has several operators. These are the arithmetic operators. So there's addition, subtraction, multiplication, and division. We're going to talk a little bit more about division in a moment. And then there's a fifth operator, remainder, or modulus, which we'll also talk about. Addition, subtraction, and multiplication work pretty much like you'd expect them to. There's not too much to say about those. Division and remainder we need to talk a little bit more about, though. Now, in terms of the division and remainder, how this works is Java treats division a little bit differently. So for division, if both operands are integers, the resulting expression of the division will also be an integer. And what happens is the decimal portion, if there is one, just gets truncated. So there is true mathematical correct division, and then there's a way that Java divides two integers, and they're very different. So again, if you have two int variables, division performs integer division, meaning the decimal portion is truncated. If you have division of two doubles, two floats, or one int with a double or an int with a float, then you'll get full normal mathematical division. Okay, so it's important to look at what the type is of the two operands to know what type of division is going to be performed. So for example, 14 divided by 5. Well, 14 divided by 5 is 2 point something, but basically the something is truncated. And so the Java result of this expression is going to be 2. The type is int, and the value is 2. Now, if we had 14.0 divided by 5, 14.0 is not an int. It's a double. It has a decimal. So now this expression is going to perform full mathematical division, and the result is going to be 2.8, which is a double. If we have 8 divided by 12, again, 8 is an integer and 12 is an integer. So this is going to perform integer division. The result is 0.66667. But because we truncate the result of this expression is going to be 0, and that's going to be an int. If, again, we change one or both of these operands to double, this will perform the full normal division. Now, in this expression, we have parentheses. Remember, parentheses are always used to force the order, so we do what's in parentheses first. So here we'd add up the 1, the 2, and the 3 to get 6, and then we'd have 6 divided by 8. Now, 6 is an int, 8 is an int, so that's, again, going to perform integer division, so the result is going to be 0. Now, here, inside the parentheses, we have 1.0 plus 2 plus 3. So now the result of the expression inside the parentheses is 6.0, which is a double. And we then divide that by 8, but now because the left operand is a double, we're going to perform full division. And so the result of this will be 0.75. Okay, so again, the bottom line here is if both operands are integers, we perform integer division. If one or both operands are doubles or floating point numbers, then we perform kind of full mathematical division. And just to be clear, the results of the expression when you perform integer division are truncated. They are not rounded. So you can see that 8 divided by 12, if one of the operands is a double, the result is 0.66666 repeating. But when we use the integer division version, the result is just 0 because the 0.666 is truncated. Again, it's not rounded to 1. It's just truncated, cut off, and the result is just 0. So it's really important to think about integer division whenever you are dealing with division of two variables, because typically you're not going to be seeing division of actual numbers, but you're going to be seeing division of variables. So it might not be quite as clear that what's going to happen is integer division. So if you're going to add up three numbers and those numbers are all integers, and then you're going to divide that, you're going to take that resulting sum and divide it by some number, that's going to be integer division. And so you have to think about that in terms of what your answer is. Now, sometimes you want integer division. Sometimes you want just the whole number division answer. Most of the time, though, you're going to want to perform the correct mathematical division. And so what you need to do is perhaps multiply one of your operands by 1.0. That would convert it into a double, thus allowing you to perform double division or full mathematical division. Now, the other operator provided by Java is the remainder or the modulus operator, and that's the percentage sign. The remainder stands for basically what is left over after you perform integer division. So make sure you understand integer division that we just talked about. And now you need to use that to be able to calculate the modulus. So if we think about x modulus y, if x divided by y is integer division, then that result is z, which is the integer portion, that's the integer division result, plus some leftover. Well, the leftover is what we can access through x mod y. So for example, if we have 5 mod 2, that's how we often say that, 5 modulus 2 or 5 mod 2, we can think about, well, what is 5 divided by 2? Well, 5 divided by 2 is 2.5, right? But if we're doing just integer division, meaning we truncate the remainder, the decimal portion, then the answer is 2. And then what's left over? What's the remainder? Well, the remainder is 1, right? Because 2 times 2 is 4, and there's 1 left over to get us up to 5. So 5 mod 2 is going to be 1. The way I often like to think about this is gold bars mod people. So let me show you what I mean by that. Say you have the expression 5 modulus 13. Think about this as there are 5 gold bars and 13 people. So the first thing you think about is integer division, meaning if we have 5 gold bars, and you can think about gold bars can't be broken up, right? You can't break a gold bar in half. So you either have to give out a whole bar or give out no bar at all. So if you have 5 gold bars and you have to divide them up evenly between 13 people, how many bars is each person going to get? Well, if you have to divide them evenly and you can't break them up, then nobody gets a gold bar. So that's the answer to the integer division, the 0. But then how many gold bars are left over? Well, we didn't give out 5, so there's 5 bars left over, and that's the modulus. So you can think about gold bars mod people, and if you think about how many gold bars each person gets, that's the answer to the integer division question, and then however many gold bars are left over, that's the answer to the modulus question. Let's think about another example. So let's actually go back up here. If we think about 5 mod 2, if we have 5 gold bars and 2 people, well, what is 5 divided by 2? That means how many gold bars does each person get? Each person gets 2 full gold bars. And then how many gold bars are left over? Just 1. So 5 mod 2 is 1. Now you can also use negative numbers. So let's look at an example with negative numbers. Let's say we had negative 11 mod 3. Well, let's think about this as if you actually owe someone 11 gold bars. So you're in a pretty bad situation here. You have you and 2 of your friends. You have 3 people, and you owe somebody 11 gold bars. Now, if you're going to pay that person back evenly, how many gold bars are each one of you going to pay? Well, if you each pay back 3 gold bars, that's fair, right? So that would be each of you owing 3. And then how many gold bars are still left over that you have to pay your friend, your debtor? That would be 2 more. So the answer to negative 11 divided by 3 using integer division is negative 3. And the answer to negative 11 modulus 3 is negative 2. So you can use this gold bars people example to think about integer division and to think about modulus, and you can do that if the operands are positive or negative. Modulus can sometimes be a little tricky to think about, especially when you have a negative number or sometimes when the smaller number is on the left-hand side. People often find that a little bit confusing. So make sure you really understand what this how the modulus operator works, because we use it a lot, and post questions you have about it to the discussion board. We can walk through some more examples. So here's one last example, 0 mod 4. First of all, let's think about integer division. So if we have no gold bars and we have 4 people, how many gold bars does each person get? This is a more realistic scenario, right? Because we have no gold bars, so each person gets no gold bars. And then how many are left over? None. Okay, so 0 mod 4 is going to be 0. 0 mod any number is actually going to be 0. Okay, here's some additional examples to walk through. If you're looking at the slides in addition to the video, I'd encourage you to pause the video, go through these examples on your own, because the next slide is going to show the answers. So pause here, work out the answers to each one of these, and then check them on the next slide. If you have any questions about any of these, post to the discussion board, and we can walk through an explanation of the answers. So modulus, what's it good for? Well, it's really good for counting by a number. So let's say you have some sort of counter. Let's say you have a GUI program and there's a button and you want to click how many times, count how many times the user has clicked the button. And let's say you want something to happen in cycles of maybe 3. So let's say, for example, you have a program and the user is clicking a button, clicking a button, clicking a button, and it's changing a light from green to red to yellow, green to red to yellow, green to red to yellow. So that's a cycle of 3, right? Green, red, yellow, green, red, yellow. But the person clicking, if you keep track of how many times they're clicking the button, that's going to increment, 0, 1, 2, 3, 4, 5, 6. That's going to go on and on and on. So we can use modulus to represent this situation. So for example, if we set the remainder to be the number of times the person has clicked that button, modulus 3, then we can just check that remainder, and if the remainder is equal to 0, then we're going to display green. If the remainder is equal to 1, then we're going to display yellow. And if the remainder is equal to 2, we're going to display red. And the remainder is always going to be equal to one of these numbers, right? Because if you're taking a mod 3, your only options for how many things, how many gold bars, for example, are going to be left over is going to be either 0, 1, or 2. You're never going to have 3 gold bars left over, because if there were, you could just divvy them up by the 3 people, right? Because this is the number of people. So you're only ever going to have 0, 1, or 2 gold bars left over. So once that person starts clicking the button 0 times, 0 mod 3 is 0, then 1 mod 3 is 1, and 2 mod 3 is 2. Then they click the button again, and 3 mod 3 is 0, 4 mod 3 is 1, 5 mod 3 is 2. They click the button again, 6 mod 3 is 0, and etc., etc. So we can use the modulus to count by a certain number. If we wanted to count by 2s, we could say click count mod 2. If we wanted to count by 5s, we could say click count mod 5, for example. And this allows us to take whatever number we have and boil it down to a certain number of options, right? Because if we're taking any number mod 3, the answer is only going to be one of 3 options. If we're taking some number mod 5, the answer is only going to be one of 5 options, 0 to 4. Okay, so modulus is really, really useful for taking a big number, or any number rather, and breaking it down into that many options. Okay? So when we think about using these operators to evaluate expressions, what we need to know about is the precedence. So what operators are you evaluated first? And to do this, what we do is we take an expression, we look from left to right, looking for the highest precedence. When we find an operator that's of the precedence that we're looking at, we stop, we evaluate the expression, replace that operator and its operands with the result, and then we keep looking till we reach the end of the expression. Then we go back to the beginning, and we start again looking for the next operator of the next lowest precedence. This is easiest to see in an example. So before we look at an example, let's talk about precedence. And there are many other things we can... So the order of precedence that we have for operators in Java is much bigger than this. We're just going to look at a subset of it. And basically, the top precedence is parentheses. So anything in parentheses, you're going to do first. Then multiplication, division, and remainder all have the same precedence. So if you encounter any one of these 3 operators, it has the same precedence. And we basically just evaluate left to right. Then addition, subtraction, and string concatenation also have the same but lower precedence. So this one comes second. This one comes third, but all 3 of these operators have the same precedence, again, evaluated from left to right. So parentheses has the top precedence. That means we can use parentheses to make an expression clearer, or to override precedence rules. So if we want an addition to happen before a multiplication, we can just put that addition inside parentheses, and that will force that to be true. When we're evaluating expressions, we can think about expressions inside of parentheses as kind of a mini expression that gets evaluated first using the same rules. So let's take a look at an example. And I'm going to walk through these this way. So let's say we have in this example, we have 4 integer variables declared, and this is our expression. So what we're going to do is we start at the left and we scan from left to right looking for the highest precedence operator. When we find that operator, we evaluate it, replace the result, and then keep on looking. When we reach the end of the expression, we go back to the beginning and we go through that process again, looking at the next level down of precedence. So the first precedence is parentheses. So we start from left to right, scan, scan, scan. We don't find any. We reach the end. We don't find any. So now we go back to the beginning, looking at the next level down, the next precedence down, which is multiplication, division, and remainder. Remember, all 3 of those operators have the same precedence. So we scan from left to right until we found one. And here we found one. So what we want to do is we want to evaluate this expression and then replace it with the result. So num3 divided by num2, well, num3 is an integer, and num2 is an integer, so this is going to perform integer division. So this is going to be 6 divided by 5, but it's going to be integer division, 6 divided by 5, so the result of this is going to be 1. Now we keep looking, so we kind of pick up where we left off, and we keep looking for the same level of precedence that we're looking for, which is multiplication, division, remainder. So here we find the next one, 1 times num4. 1 times num4 is 4. So now we keep looking, keep scanning. Up here we find another operator with the same precedence, and we have num1 mod num3, so that's 3 mod 6. So if we have 3 gold bars and 6 people, how many gold bars are we going to have left over after divvying up the gold bars? Well, everyone's going to get no gold bars, and there's going to be 3 left over. Then we keep scanning, we reach the end, and we're done with that level of precedence. So now we go back to the beginning, and we start scanning again, looking for the next level down, which is addition, subtraction, and string concatenation. So we scan, scan, scan. Oh, here we find one. So num2 plus 4 is going to evaluate to 9. Oops. So now we keep scanning, and here we find one. 9 plus 3 is going to evaluate to 12. Keep scanning. 12 minus 5 is going to evaluate to 7. And now we've reached the end, and our expression is evaluated. So the result of that whole big expression is 7. Let's walk through another example. I'm going to encourage you to, again, pause the video, do this example on your own, and then come back and watch the walkthrough and see if the result matches what you got. So remember, when we're evaluating these expressions, we start from left to right, looking for the highest order, replacing all expressions with their result, and then when we reach the end of the expression, we go back to the beginning and do it again. So here we're going to walk through looking for the highest order of precedence, which is parentheses. So we scan, and we find them. So now we stop and we treat the expression inside the parentheses as a kind of mini expression, meaning we do the same evaluation on this expression that we would if this was all on its own. So we start from the left and we scan left to right looking for the highest precedence, which is, again, parentheses. So we scan left to right, no parentheses inside. So now we go back to the beginning, scan left to right looking for the next level down, which is multiplication, division, and remainder. So we're scanning. Oh, we find one. So now we replace num3 times num1 with the result, which is 18. Then we reach the end, so we go back to the beginning and we scan for addition and subtraction. We find one, and we replace sorry, did I do that last one right? Num3, 6 times num1, yeah, okay, sorry. Num2 plus 18, which is 23. So we replace this whole expression with 23. Then we would continue looking for any other parentheses expressions, at which point we reach the end and we are done. So now we go back to the beginning and we scan for our next level of precedence, which is multiplication, division, and remainder. So here we find one here, num3 divided by 23. And both num3 and 23 are integers. This is going to perform integer division, which is going to give a result of just 0. Keep looking, keep looking. We don't find any with that same precedence. We reach the end. So now we go back to the beginning and we scan looking for our lowest order of precedence, which is addition, subtraction, string concatenation. Num2 plus 0, we replace with a 5. 5 plus num3, we replace with an 11. And 11 minus num2, we replace with a 6. Okay, so that's your general procedure for evaluating complex expressions. Now, I'm going to make a note here that you shouldn't actually really include long, complicated expressions like this in your code because it's very likely that someone will make a mistake in evaluating the expression. But you should know how to evaluate these. So this is not good programming practice to necessarily string lots of things together like this. It would be better to use more parentheses or to put things into multiple expressions. But again, it's important to know how to evaluate things if you do happen upon something like this. So let's look back at our levels of precedence. We have parentheses, multiplication, division, remainder, addition, subtraction, string, concatenation. And now we're going to add a fourth one to the list, which is the lowest on the list, and that's the assignment operator. So that's our equal sign. This is lowest on the list. Again, this means that what you do is you do everything on the right, so you do all of your complex expression on the right, and then and only then do you take that resulting value and store it into the value on the left. So the assignment operator is actually an operator, and it's the lowest in precedence. That means it happens last. So if, for example, we had this, these are the same two expressions from our previous example. If we had gone ahead and evaluated this whole first expression like we previously did, we would do all of that stuff on the right-hand side first, and only then store it in a variable num5. Same thing if we'd done this whole expression on the right-hand side first, and evaluated it and gotten, what did we get there? 6. We would then and only then store it in the variable on the left-hand side. So that's our last operator. Now you'll notice in this second example, the operator that we're storing into is num2, which is also, the operand that we're storing into is num2, which is also one of the variables we used in our calculations. Now this wouldn't change the calculation because we would use the current value of num2 to evaluate the right-hand side. So we'd use a 5 here, here, and here. And we would use that to calculate the value, and only after we calculate the whole right-hand side would we then update this value and change num2 to be equal to 6. Okay, so again, this equal sign is the very last thing we do. It's almost like you can just ignore this left-hand side for a long time until you're completely done, and only then worry about assigning the value. Now, in addition to the operators we've already looked at, we have a couple more. The operators that we looked at previously are binary operators, meaning they take two operands, a plus b or c divided by d. A unary operator is an operator that only takes one operand. That means you only have one variable that it's associated with. Now, the two most commonly used unary operators in Java are the increment and decrement operators. Increment is plus plus, and decrement is minus minus. Plus plus basically adds 1 to the value of your variable. So if you write num plus plus, that is the equivalent of writing num equals num plus 1. And if you write num minus minus, that is the equivalent of writing num equals num minus 1. So you're welcome to always write it out, num equals num plus 1 or num equals num minus 1. But because incrementing and decrementing by 1 are something that we do so frequently in programming, Java gives us a nice shorthand operator of plus plus and minus minus. The unary operators, ones we just looked at, are called postfix because we put the operator after the variable. Those come second in our order of precedence. So if we now update this list, we've got parentheses. Then if you've got any increment or decrement operators, that would come next. Then would come multiplication, division, remainder, then addition, subtraction, concatenation, and then assignment. This list of precedence is not something you really have to memorize. You can always look this up in a textbook or online. You should have a general idea of what comes before what, but this is a common one that you might not remember exactly where this comes in the order, but you can always look it up. Now, in addition to the equals assignment operator, there are actually other assignment operators that Java gives us that can be very helpful. So there's plus equals, minus equals, and then also times equals, divide by equals, and modulus equals. Although plus equals and minus equals are the two that we see the most commonly used. Plus equals is basically the same as saying the variable on the left equals itself plus the variable on the right. So if we have num1 plus equals num2, that is the equivalent of saying num1 equals num1 plus num2. And if we had num1 minus equals num2, that is the equivalent of saying num1 equals num1 minus num2. So it basically takes whatever is on the left and then performs the operator on itself and the value on the right, and then takes that resulting value and uses it to update the variable on the left. So let's take a look at an example. Before we do that, though, the assignment operators plus equals and divide by equals work the same as their underlying arithmetic operator. So if we have a plus equals and one of the operands is a string, plus equals is going to perform string concatenation. And if we have a divide equals and both of the variables are integers, then divide equals is going to perform integer division. So plus equals works the same as plus in terms of whether it performs addition or concatenation, and divide equals works the same as divide in terms of whether it performs integer division or full-blown division. So now let's take a look at an example. So here we have three variables, and then we have an assignment operator. So we're going to start by evaluating this expression just like we do with all the others. Those assignment operators, just like equals, are lowest on the precedence. So this assignment operator is actually assignment operators, but it comes last. So we can essentially just ignore this part for a while. All right, we're just going to pretend that isn't there, and we're just going to evaluate the right-hand side just like we did previously. So we start at the left, and we start scanning for the highest precedence, which is parentheses. We don't find any, so we go back to the beginning. We start for the next level precedences, which would be increment and decrement. Don't find any, so we go back. Start for the next level, which is multiplication, division, remainder. Okay, we find one. So num1 times num3 is going to be replaced with an 8. Then we keep scanning. Oh, now we reach another one. Num3 divided by num2. That's going to be 2 divided by 3, but it's integer division, so that's going to be 0. Keep scanning, keep scanning. Now we've got num1 mod num2, so that's 4 mod 2. The result of that is going to be 0. If you have 4 gold bars and you're trying to divide them evenly between 2 people, you won't have any left over. Then we keep scanning, and we reach another modulus, 0 mod num1. Remember, 0 mod any number is going to be 0, because if you have no gold bars, no matter how many people you have, you're not going to have any gold bars left over. Then we reach the end, so now we go back to the beginning, and we have 8 plus 0 evaluates to 8. 8 plus 2 evaluates to 10, and 10 minus 0 evaluates to 10. So now our very last order of precedence is the assignment operator, and we have one of those. So we can think this final result is num1 plus equals 10, and if we want to, we could rewrite that as num equals num1 plus 10, which is going to evaluate to num equals 14. Oops, sorry, num1 equals 14. Okay? One last example here. I'm going to leave this one for you to do on your own, and I encourage you to post your answer to the discussion board. This last example brings together a lot of things with precedence in terms of parentheses, integer division, full division, as well as the use of an assignment operator. So please walk through this practice example and post your answer on the discussion board.